Hopefully you guys doing great. Just want to get us started here and answer any of you guys' questions about the upcoming tests and all that kind of stuff. So just say hi if you're there. And before we get started on anything, let me just mention that you guys should already know this, that the answer key of the review guide is already up on OneDrive. It's been up on OneDrive forever, and it's already up there if you guys wanted to check it out. But I'm going to take some time to go through all the problems because I want you guys to, if you're struggling with anything, to be able to see how I would go about solving them, and so that it gives you a little bit of a better idea of the approach to take when you actually take the actual test. Okay, so I see a few of you guys here with me. Not a lot of people, so I don't know. Hopefully everybody here actually knows that we do have a test tomorrow. So if you're here, say hi and say, "Oh, I knew that we had a test tomorrow." That would be great, so that it doesn't take people by surprise. It is on Fax. It's on Google Classroom. You guys should know about it, and we talked about it last time in class. But again, not everybody shows up to class, so whatever. And it's okay if you're sleeping right now and you don't get up till noon. That's fine today, and you can go through. You can watch this video later on. But if you are sleeping through class tomorrow, that's going to be a problem, right? You have to show up to class on time in order to be able to actually. It's not a good connection. Uh-oh, that's not good. You need to show up to class on time in order to actually be able to get credit for the test. Okay. So if you don't have a good connection, maybe there's some kind of internet issue. I think, Anna, you had some connection problems last time too. I don't know. It might work better for you not to watch the live version and then watch it later. It might actually work better. I don't know. But anyway, so it is what it is, and that's the best that we can do. So yeah, I'll just stop with that. All right. Good morning. All right. So let's start off, and I just want to say about the test before we jump into solving this. All of these, so right here, these kinds of definitions, you're not going to have that on your test. There's no real point for us to do any kind of definitions on your test, but so it's good for you to know them. You might see one of them in a fill-in-the-blank type question. You might, right? But I don't know. So I'm not going to worry about taking time to go over that. And you can see if you want the definitions for any of these, you guys can already check out on the answer key on OneDrive and look at, okay, we got the definitions for all these things. So I'm not going to go over that, okay? What I want to do is I want to jump right into the questions themselves and work through them to make sure that you guys are able to solve these on the test day, okay? Once again, the test is going to be open notes. You can have a periodic table. You can have a calculator. You can have, what would be super helpful is for you to have your completed review guide, okay? And you can have that during the test. You can look back at it. Keep in mind that the reactions are going to be different, so balancing them is going to be different, right? The reactions are going to be different, the numbers are going to be different, but the setup of the test and the types of questions are going to be the same. So this should be super helpful for you guys. And without further ado, let's just jump right into it. Okay? So any of these types of problems, you are going to have to, in this case, it actually tells you first balance the reaction. So make sure you obviously balance the reaction first. If you don't balance the reaction, everything else is going to be pretty much wrong. So you better balance the reaction first. Okay? So this one is a reaction that you've seen, guys. You've seen this before, Haber process. So we can start with the nitrogen, right? You got 2 here. So we're going to go ahead and put a 2 there to balance the nitrogen. That gives us 6 hydrogen, so we need to put a 3 in front of that, and we have a balanced reaction. Okay? Now, on the front page, so let me just push this up. On the front page, all these questions are going to be moles to moles questions, and because they're moles to moles questions, they're going to be one-step conversions. So if you find yourselves doing some kind of 3-step conversions on the front page, you're making a mistake. The front page is designed to be easier. The front page is all one-step moles to moles conversions, and your conversion factor through the entire front page is going to be the balanced reaction. you will not need to calculate any kind of molar masses on the front page, right? Because you don't need the mass. The molar mass is only needed when going from grams to moles or moles to grams, but we have all moles to moles problems here, so we don't need any kind of molar masses. All we need is one-step conversions. So hopefully you guys have already done this. You've already solved all these problems, and if you haven't, you might want to just close out now and do it yourself, and then come back on YouTube later, and then you can watch all this later. That's fine. But if you've already solved it, great. So let's go ahead and just jump into it. The maximum amount of NH3 that can be made from 5 moles of N2 is blank, okay? So we're starting with 5 moles of N2, and we want to know how much NH3 we can make. So you could even do this in your head, but let me just write it down anyway. So if we have 5 moles of N2 to start, and we want to figure out how many moles of NH3 that you can make, what you're starting with is always going to go on the bottom. So we have N2, that's going to go on the bottom. What you're solving for is going to go on the top, NH3. And so we just look back to the balance equation for our numbers. So we have just one, right? There's no number in front of N2, so it's going to be 1 N2 here, and NH3, there's a 2 in front of that, so it should be 2 NH3 there. So that means our answer is going to be 5 times 2 divided by 1, which is 10. 5 times 2 is 10. So we can just write that right here in the blank. The maximum amount of NH3 that can be made from 5 moles of N2 is 10 moles. Okay? So that's how we're going to start off, just doing these one-step problems. We're going to do the same thing down here. The maximum amount of NH3 that can be made from 12 moles of H2. So we have 12 moles of H2. And once again, we're solving for NH3, right? These two questions are both asking for the amount of NH3. So, since we're both solving for NH3, we should expect this top to be the same, 2 NH3. All right, but we're starting with H2 on the second problem, so we go back to the balance reaction and we find, okay, there are 3 H2s in the balance reaction. So this problem, once again, we could probably do this one in our heads. You're welcome to do this in your calculator if you want, right? It's going to be 12 times 2 divided by 3. And so that's going to be, or 12 times 2/3, however you want to think about it. Anyway, but 12 times 2 is 24. 24 divided by 3 is 8. So this should be 8 moles of NH3. And we can just write 8 here in the blank. Okay? So once we have that, these questions are going to be based off of these two questions up here. Okay? And so we don't need to do any new calculations. When it says the limiting reagent of Bob's reaction, we don't need to do a new calculation. We just look back here. Remember, limiting reaction or limiting reagent problems always involve looking at the two different reactants and figuring out how much product they can make, which is exactly what we did right there. Okay, so the limiting reagent of Bob's reaction is the reactant that makes the smallest amount of product. Well, the smallest amount of product is 8, and the reactant that made that is, well, H2. So H2 is the answer there. Now, the theoretical yield is that smaller amount. So we look at 10, we look at 8. The smaller of those two must be the theoretical yield, because once you make 8 moles of NH3, you can't possibly make more because you've already run out of all of the H2 you have. So the theoretical yield is going to be the smaller of those two numbers, which is 8. Okay? The actual yield, well, where do you get the actual yield? If we were doing a lab, the actual yield would be the amount that you weighed. And so we're going to look back at our question. The actual yield is always in the question. So you look for the actual yield, we're going to look back over here, and we're going to find, oh wait, he only collected 6 moles of ammonia. So that is our actual yield. The actual yield is what he collected. Look for that key term there. All right, it's going to be 6 moles. Okay? Notice these are all whole numbers. On your test also, you will have all whole numbers on the front side. On the back side, no, that's going to be different on the back side. So here we go. The percent yield is what? You guys should know this. It's going to be actual divided by theoretical, right? Actual divided by the theoretical yields, okay? And that means it's going to be 6 divided by 8, and we know 6 divided by 8 is the same as 3 over 4, and 3/4 is 75%. Okay, if you need to use a calculator, that's fine. No shame in that. 6 divided by 8 in your calculator, you'll end up with 0.75 times 100 is 75%. All right. Next, last of all, we have there is an excess of what? What does that mean, an excess? Excess means which reactant is there leftovers? Which reactant didn't get used up? And that is going to be the other one, not the limiting reagent. It's always going to be the other one. So if H2 is the limiting reagent, right? If H2 is the limiting reagent, the other reactant must be the excess. So we're going to have N2 is the reactant that is in excess. Okay? So last question here. If Bob wanted to have no reactant in excess, so let's suppose Bob, this is a new situation here. Bob's going to redo this reaction and have nothing left over. Okay? So he didn't want to waste anything, right? You know, kind of like you don't want to waste any toilet paper because there's hardly any toilet paper, right? So same idea here, right? So Bob wanted to have no reactant in excess, doesn't want to waste anything. So he wants to combine blank moles of H2 with 3 moles of N2. So we have 3 moles of N2 and we want to figure out how many moles of H2. So we're going to take our 3 moles of N2 and we want to convert that somehow to H2. And we're going to do that by looking back at the balanced reaction, right? If we're starting with N2, right, we have 1 N2 from the balanced reaction. And for every 1 N2, there are 3 H2s. So we're going to put a 3 H2 on the top there, okay? And that's going to be a math where we're going to do 3 times 3 divided by 1, which is 9 moles of H2, or I'm just going to write 9 right here in the blank. Okay? So that's the front page. Notice the whole front page, I didn't calculate a molar mass. I didn't have any decimals. Everything was all nice and neat, whole numbers. You will see the same kind of thing on your test, but it'll be different chemicals, different reactants, and different numbers. But same idea. All right, questions on the front side. Okay, if there are no questions, let's go to the other side. Now, the other side, I mean, this should be the test the whole year that you're the most prepared for, right? Because you know exactly what this is going to look like. The back side on your test is going to be just like this. Different reactions and different numbers, but you will have 2 problems on the back side. Just like this, there'll be 2 problems, and they'll be asking the same kinds of things. You'll literally see the same kind of wording, right? If the reaction worked perfectly, how many grams should you collect? What's the percent yield? Same kind of question here, and then down here, you're going to be figuring out what's the limiting reagent. So same kind of thing there, all right? Can you explain what you did for number 9, please? So let's go back. So at question number 9. So we'll go back over here to number 9, and then we'll go back to the last page. All right, so what did I do? I'm doing the same kind of thing, moles to moles problem, right? So moles to moles problem, so it's a 1-step thing, but rather than going from, let's say, from a reactant to the product or from the product to a reactant, we're going from one reactant to the other. And you can always do that, okay? So let's just set up a different possible one. Let's suppose you had 10 moles of N2 and you wanted to figure out how many moles of H2 you could react that with to have nothing left over, all right? So then we're going to do a 1-step conversion. You look back over here and just say, okay, for every 1 N2 that we have, you need 3 H2, okay? And once again, this is going to be 10 times 3, or 30 moles of H2. What does that mean? That means for every 10 moles of N2, you need 30 moles of H2, and you'll make 20 moles of NH3. You could go the other way too. Let's suppose we had, let's say, 6 moles of H2, and we want to know how many moles of N2 you can make. Well, same thing, all right? If we're starting with H2, we're going to put our 3H2 on the bottom, and we want to solve for N2, so it's going to be 1 N2 on the top. So in that case, it's going to be 6 times 1 divided by 3, or 6 divided by 3, which is 2 moles of N2, okay? And so this is just going to basically be able to allow you, and in fact, the balance reaction will allow you always to go from any chemical in that balance reaction to any other chemical. So typically we go from reactant to product, but sometimes you might go from reactant to reactant, or sometimes you also might go from product to reactant. You can do any of those conversions, all right? They will all be the same way. Moles to moles is 1 step, grams to grams is 3 steps. So let's flip it over. Let's go to the back side, and I've got a little bit of a lag here with my own live stream, but let's see. So for the back side, let's tackle problem 10 first and go down to problem 11, and we'll be done, okay? So what do we need to do first? Balance the reaction first, of course. Always, always, always balance that reaction first. So in this case, we have H2O2 splits up, breaks down, decomposes to water and oxygen because only these two things have hydrogen, and this is 2 hydrogen, that's 2 hydrogen. Hydrogen is already balanced. You need to make sure that the numbers in front are always the same. So there's a couple ways we could do this. Since we have 2 oxygens here and 1 here and 2 there, we could put a 1/2 in front of the O2, balance it right away, and then multiply everything through by 2. Or we could just simply recognize, well, I have 3 oxygens over here. I need to increase the amount of oxygens on this side, so I'm going to put a 2 in front. That's going to get me 4 oxygens and 4 hydrogens. So I need to put a 2 in front here to give me 4 hydrogens, and 2 oxygens plus 2 is 4. So it's all balanced now, okay? So that's a balanced reaction for you guys. And let's go ahead and jump right into the problem. All right, what is it saying? Hydrogen peroxide, this thing, it decomposes according to that equation. We're going to perform that decomposition with 15 grams of H2O2 and collect 6.3 grams of O2. Now, before we try to do any math on this, right, I want us to recognize that this collect 6.3 grams of O2 is what? What is that? That is the actual yield, right? The actual yield, when you see that collect or make or create or yield or something like that, that's going to be your actual yield, and you're not going to do any calculations with that except for percent yield calculations. Okay? So, what are we going to do calculations with? This 15, because the 15 grams, that's the amount of reactant that you start with. So let's just go ahead and write that down. We have 15.0 grams of H2O. And I really want you guys to do this. I want you to write down the number, the units, and the chemical. Don't get sloppy here, guys. Really, don't get sloppy. Getting sloppy does 2 things. First of all, it will lead to sloppy mistakes. And secondly, I might even take off points for not sufficient work being shown. Okay? So show your work, write down the number, the units, and the chemical, and it will all work out better. It'll show you what you guys need to write down. It'll show you what cancels out. It is the way to go. Now, if we have grams to grams, you already know that it's going to be a 3-step process. Now, you don't have to start off this way and write them all down, but I'll go ahead and do that because I feel like it, okay? It's going to be a 3-step process, and the first step is going to be going from grams to moles. The middle step is always going back to that balance reaction, and the last step is going from moles back to grams. So you're going to have a molar mass here and a molar mass up here. So the molar masses that we need, oh wait, I made a mistake. This is 15 grams, not of H2O, but 15 grams of H2O2. So I'm going to make sure I put that in there. And we're going to need a molar mass of H2O2, right? So the molar mass of H2O2 is going to be calculated from the periodic table. So it's going to be 2 times, and let's just bring this down for your reference, right? H2O2 has got 2 hydrogens, so it's going to be 2 times 1.0079 plus 2 times for oxygen. It's going to be 15.999. Okay, 15.999. Let's total that up. Two times 1.0079 plus 2 times 15.999 gets us the molar mass of hydrogen peroxide is 34.0138 grams per mole. Okay? Now, let's go back to the problem here. We are starting off with 15 grams of hydrogen peroxide, and we want to come up with or figure out how many grams of oxygen that you should make. So the first step is going to go from grams to moles, and we will need the molar mass of hydrogen peroxide. If we're starting with grams, grams are going to go on the bottom, so it's 34.0138 grams is 1 mole of hydrogen peroxide. Next, we're going to go from moles of hydrogen peroxide to moles of oxygen. So what we're starting with goes on the bottom, H2O2. What we're solving for, O2 goes on the top. And we look back over here for the numbers. Hydrogen peroxide has a 2 in front, and oxygen has nothing, so that's simply 1 right there. The last step, we've gone from grams of hydrogen peroxide to moles. We've gone from moles of hydrogen peroxide to moles of oxygen. Last of all, we want to go from moles of oxygen to grams. So we need the molar mass of O2, which is going to be 2 times 15.999. Okay, so 2 times 15.999, which is 31.998 grams per mole. Okay? Notice, oops, sorry about that. Notice a couple things, all right? When I calculate molar masses, I include these subscripts in the molar mass calculation, but I did not include this too. You don't include numbers from the balance reaction in the molar mass calculation. It's only going to be the subscripts that are in the molar mass calculation, not these numbers, not the coefficients in the balance reaction, okay? Now, I think we're ready to do the calculation here. Let's see if you can see that. All right. So it's going to be 15 multiplied by numbers at the top, divided by numbers in the bottom, divided by 34.0138, divided by 2 times that molar mass, which I already have in my calculator. Enter. And that's my answer. 7.0555. All right, and I have 3 significant figures because I'm starting off with 3 significant figures here, so it should be 7.06 rounded off to 7.06 grams. I probably will not be too picky about significant figures, so don't worry about that, although try to get it right, okay? 7.06, 3 significant figures here. Notice the actual yield has only 2 significant figures, but that's not part of the calculation, so our answer should have 3 significant figures. So that is the amount of oxygen that we should be able to collect, right? We should be able to get 7.06 grams of oxygen, but we don't. We actually only collect 6.3 grams. So our percent yield is going to be the actual yield over the theoretical yield times 100. So that's going to be 6.3 divided by 7.06. And I'm going to use the number I have in my calculator. That way it doesn't lead to any kind of rounding errors. Sometimes it won't make a mistake, but sometimes it's best to just leave that in the calculator. So 6.3 divided by second answer. Again, using the number I have in my calculator rather than any kind of rounded answer. And that's going to get me 0.89. So I'm going to multiply that by 100 to make it into a percent. That's 89%. 89%. Okay. Notice I have two significant figures there, so I should have two significant figures there. All right. 89%. All right. Hopefully you guys got that. Any questions on number 10? 89%. Okay. Without any questions for that, I'm going to jump down here to do number 11. All right. So, what's the first thing I should do on number 11? Before anything else, make sure you balance the reaction. Okay? I'm going to look at the iodides first because they're, it kind of jumps out at me. So I have one iodide there, two iodides there. So I'm going to put a 2 right there to balance that. That's going to get me 2 potassiums. So I want to have 2 potassiums over here to balance that. That's going to get me 2 nitrates. I already have 2 nitrates over here, and I have 1 lead, and I have 1 lead, so everything's already balanced. Those 2 2s take care of it. Now, this question says if we combine 25 grams of that and 35 grams of that, which reactant would be the limiting reagent? And that's it. All it's asking is which is the limiting reagent. But you must show your work, okay? If you don't show your work, if you just guess, you will get a 0, okay? I'm not going to give you any points even if you just guess it right by chance, okay? You must actually show your work through a calculation. It would be silly not to. So what we're going to do is we're going to take both of those numbers and calculate how much product that you could make from that, all right? And so what I'll do is I'll write down let's use a different color here. I'm going to write down my 25 grams of PbNO3 2, and I'm going to write down my 35 grams of my Ki, and I'm going to calculate the amount of product that I can make. Okay? Now it doesn't tell me, so it just says which is the limiting reagent, and it doesn't tell me which product to solve for. So which product should I solve for? It actually doesn't matter. I could solve for PbI2 or I could solve for KNO3. Either way would work. Okay? And in fact, I could solve for moles of either one of these, or I could solve for grams of either one of these. So there's literally 4 possible ways to set this up. Okay? I'm going to do a grams to grams problem because you guys are more used to that, but you could do a grams to moles problem, which would work fine. On the answer guide, answer key that I gave you guys on the study guide on OneDrive, it solves for, I believe, I solved for PbI2. Right? But just for fun, I'm going to do it a different way right now. I'm going to go ahead and solve for KNO3. Either way is fine, as long as you solve for the same product here as here. Okay? The biggest mistake you could make would be to solve for PbI2 here and then KNO3 here, or vice versa. You must solve for the same exact product. Okay? So without further ado, let's go ahead and do that. I am going to go ahead and set this up in a grams to grams fashion. And of course, you could just go from grams to moles and make it a 2-step one. But we've done a lot of these, so I'm going to go ahead and solve grams to grams. And so the first thing that I'm going to need to do is solve for the molar mass of this and solve for the molar mass of that. And you'll notice that any of these, the tops of these 2 setups are going to be identical, and the tops here, the top left is always going to be 1 mole because I need to always first convert it to moles, and the bottom right is always going to be 1 mole, 1 mole. All right, so that reminds me this is a molar mass, and it's a molar mass of this thing right here, the PbNO3 So these are going to be kind of big numbers because lead and iodine are fairly heavy elements. So lead, if you look back on your balance on your periodic table, lead is right down here, 207.2. So that's going to be 207.2 plus I have 2 nitrogens, right? So I have 1 times 2 or 2 nitrogens, 14.007. Plus I have how many oxygens? 3 times 2, that's 6 oxygens. 6 times 15.999 is going to get me 331.208 grams. Okay? So once I've got the molar mass of the PbNO3 now I need to convert that to the product. So I look back at the balance reaction. If I'm starting with PbNO3 I have only one of those, or no number in front, so it should be 1 PbNO3 in the bottom, and whatever I'm solving for at the top. Now I could choose either one of these products as long as I make it the same here and here. So I'm going to choose, just for a little variety, I'm going to make this 2KNO3 at the top here. Okay? And then last of all, I need the molar mass of whatever you put here, you need to put the molar mass right there. Okay? And so that's going to be KNO3, potassium nitrate. Potassium is 39.0983 from the periodic table, plus nitrogen, there's 1 nitrogen, that's 14.007, and there are 3 oxygens, so it's 3 times 15.999. That gets me 101.1. 101.1023 grams, okay? Now, what you can do right now at this point in time, because we must solve for the same product, what you can do is you can say, okay, the tops of these are all going to be the same, okay? So this, you must be solving for the same product, so I'm going to put 2 KNO3 here, and I'm going to put the molar mass right here, 101.1023 grams there, okay? Those tops must be the same, which makes this a little bit easier, right? So let's finally put this in our calculator and solve this stoichiometry problem. It's going to be 25 multiplied by numbers at the top, divided by numbers in the bottom, divided by 331.208 times 2 times that 101. I already have it in my calculator, so I'm going to do second answer, and that's going to get me 15.26. Let's round it off to, I really only have 2 significant figures here, right? I started off with 25 grams, so I'm just going to round that off to 15 grams. And you can write down more digits. All right, 15.3 would probably be good. You get a little bit more information, but let's just stop there, 15 grams. Okay? Same thing here in the bottom, but we're starting with a different reactant, the potassium iodide. So I need to calculate the molar mass of potassium iodide. So that's going to be potassium, which is 39.0983, plus iodine, which is 126.9, and that's 165.9983 grams per mole. Okay? Notice once again that for this potassium iodide, I don't have any subscripts, so I don't multiply either the potassium or the iodide by anything, and that 2 is not a part of the molar mass there. Okay? All right, one more thing to fill in. If I'm starting with potassium iodide, on the bottom here, I need to have potassium iodide, and I have 2 potassium iodides. So that's all set up. All right, let's put it in our calculators. It's going to be 35 divided by numbers in the bottom. And I have that in my calculator already. Times 2 over 2, which you can put in your calculator, but it's pointless because 2 over 2 is just 1, times that molar mass, 101.1023. And that's going to get me my final answer here of 21.3, or simply 21 grams. All right, I'm done with the math. I just need to interpret it. Almost done with the problem. The problem asks me, which reactant would be the limiting reagent? Only one question here. The limiting reagent is going to be the reactant that makes the smaller amount of product. And so we see, okay, well, the 15 grams, that's the smaller amount of product, which means that this right here is the limiting reagent, okay? The PbNO32 makes the smaller amount of product, so therefore it is the limiting reagent. All right, questions? Questions. We are all done. I'm all done everything I want to talk about. We're all done going through the sample test, and your test is going to be just like this, but different chemicals, different reactions, and different numbers. So, what do you guys think? Can you do it? Yes, I know you can do it. All right, questions? Okay. So, all right, well, it's going to be, I'll probably upload the test, like a couple minutes before class. Not a whole lot before class, but about 10:10-ish, thereabouts, you'll see the test uploaded, maybe a couple of minutes before that, I'm not sure, right? And you're going to have one class period to do it in. So your test will end at 10:55. You're going to need to upload it. So try to make sure that you work diligently. If you print it out, you print it out. That's probably the best thing to do. Or if you can do it on Notability, that's maybe even better because it looks pretty good on Notability. From what I'm hearing from people, if you just save it as a Google document, then you can upload it or load it into Notability and do all your work there, and then save it back into Google Documents, upload it onto Google Classroom, and that'll be the best. But maybe you're afraid of glitches or it not, having problems with the whole electronic stuff. So you're welcome to print it out and take a picture at the end. That's great. I like to use paper, so if you want to use paper, print it out, take a picture, upload it, make sure the picture is a nice picture, but upload it before the due date. Okay? So you're welcome to use any notes during the test. You're welcome to use a periodic table, calculator, all that kind of stuff. The only thing that you may not use is other people. So you may not talk to other people about the test. You may not ask other people about the test, whether virtually, in person, or otherwise. You may not ask a artificial intelligence about the test. You may not do anything like that. It is your own work and only your own work, but you may use whatever resources you need. Okay? So see you guys tomorrow. Have a great night's sleep, and see you guys.